is the smallest unit of ordinary matter that forms a chemical element. Every solid, liquid, gas, and plasma is composed of neutral or ionized atoms. Atoms are extremely small, typically around 100 picometers across. They are so small that accurately predicting their behavior using classical physics, as if they were tennis balls, for example, is not possible due to quantum effects. Every atom is composed of a nucleus and one or more electrons bound to the nucleus. The nucleus is made of one or more protons and a number of neutrons. Only the most common variety of hydrogen has no neutrons. More than 99.94% of an atom's mass is in the nucleus. The protons have a positive electric charge, the electrons have a negative electric charge, and the neutrons have no electric charge. If the number of protons and electrons are equal, then the atom is electrically neutral. If an atom has more or fewer electrons than protons, then it has an overall negative or positive charge, respectively. Such atoms are called ions. The electrons of an atom are attracted to the protons in an atomic nucleus by the electromagnetic force. The protons and neutrons in the nucleus are attracted to each other by the nuclear force. This force is usually stronger than the electromagnetic force that repels the positively charged protons from one another. Under certain circumstances, the repelling electromagnetic force becomes stronger than the nuclear force. In this case, the nucleus splits and leaves behind different elements. This is a form of nuclear decay. The number of protons in the nucleus is the atomic number and it defines to which chemical element the atom belongs. For example, any atom that contains 29 protons is copper. The number of neutrons defines the isotope of the element. For example, a copper atom with 34 neutrons is copper 63, and with 36 neutrons is copper 65. Natural copper is about 70% Cu-63 and the rest is Cu-65. Atoms can attach to one or more other atoms by chemical bonds to form chemical compounds such as molecules or crystals. For example, New York City's Statue of Liberty was originally made of pure copper, but over the years, the surface combined with oxygen, carbon and sulfur atoms to make a green patina on the copper. The ability of atoms to attach and detach is responsible for most of the physical changes observed in nature. Chemistry is the discipline that studies these changes.